Okay, so now we're going to explore Newton's laws in 2 dimensions, and as we continue to explore this here, let's say we were pushing a chair like this, and we wanted to draw the forces. In this case, as the person pushes, there's probably a downward component of that force applied. Therefore, we have the force of gravity, but because this force applied is over at an angle, if we broke that up, there's a certain component this way, but there's also a certain component downward. If there's both of these downward, there's going to be the counteracting normal force, which is going to be strong, which would be counteracting the force applied downward and the force of gravity. An important thing about the normal force is not always associated with weight. If we had a situation like this where we're pushing a block against the board, we have an applied force this way. The normal force would actually be backwards from the board. It's perpendicular to the surface. Weight would be trying to pull the block down, and then friction's actually holding it up. So it's important to notice that with the normal force. Most of the time the normal force equals the weight of the object, but that's not always true because, like we saw before, if there's an upward component or a downward component, there can be a difference there. So what we're going to do in this first one is to look at what happens as we push a garden mower and a push mower. And so in this case, we're pushing down on it at an angle of 32 degrees with the surface of the lawn. So if you want to draw the free body diagram here, we have the normal force going up, force of gravity down, and then this force applied at an angle. And if we break this up, we could break this up into two portions. We have the force applied in the x, and we have the force applied in the y. Force applied in the y is going downwards, force applied in the x is going this way. And when we set up the sum of the forces, we're going to have to consider the forces in the x and y. And so when we do that, we have the force applied in the x, force applied in the y. We set up our trig to figure out what those actually are. So the force applied in the x is 211.16, force applied in the y 131.95. And so if we look at the sum of the force in the x, there's actually only one force listed here, and we've got that. But really what we're trying to find out is what is the normal force. That's the goal of this question. So when we set up the sum of the forces in the y, we have the positive normal force plus the negative force of gravity plus the negative force applied in the y, because the force applied in the y is downwards. Because this mower is being pushed into the ground some, the normal force has to compensate and become greater. So what we have here, we have the force of gravity, which is the 21 kilograms times 9.8 for the force of gravity. We have the force applied in the y, which is acting downwards. And the counteracting normal force would be 337.75. And so we would get that as a normal force. Okay, so now we're going to take a look at a situation where an object's being pulled and pushed at the same time. So in this one, Larry pushes a block 45 degrees angle below the horizontal, and Mole pulls the same block horizontally with 120 newtons of force. So let's call the downward force here force A, and this one force B. We're going to do this the same way, where we're looking at the sum of the forces in the x and y. We're going to break up the force applied into the force applied in the x, force applied in the y. Then we can solve for the different values here, so the force applied in the y and the force applied in the x. And then we can set up the sum of the forces. So in the y, we have the positive normal force, negative force of gravity, and then the negative force applied in the y. Those are acting downwards. For the x, we have the positive force B and then positive force applied in the x. And we can determine these values from what we have here. So with the acceleration of the block, we have the force applied in the x plus the normal force divided by 200. So that's the acceleration in the x. For the normal force, 200 kilograms times 9.8, that's acting downwards. And then we have the force applied on the y, which is downwards to both acting downwards 2066. And then we can find out the force on this one, and this is a good practice to look at how forces are balanced. So we have three forces. We have the force applied acting towards the right here. We have the force B acting downwards. And so the question is, find the direction and magnitude of the third force acting on the object if the net force is 0. And so when we set this up in variable form, we have the forces FCX, FCY, and we got to figure out, how much those are to be able to figure out, what this third force is here. So we have the sum of the force in the x equals ma in the x, and so the positive force applied plus the negative FCX, and then we can figure out what that force needs to be. So that would be 6.5 to counteract the force applied to the right. So the net force would be 0. And then for the forces in the y, FCY, and then the negative positive FCY, and then negative force B downwards, and those have to cancel each other out as well. So we know what the y force would have to be, what the x force would have to be. We can bring that on a coordinate axis and determine what that net force would need to be, and that would come out to be 7.85 newtons at 34.09 degrees north of west. So that would be the force to counteract this force and this force to make it have 0 net force.